Dear students, today we will read about shear force and bending moment diagram. Actually, this topic is important from the point of view of the beams. Whenever we are designing the beams for various structures, there we have to check whether the beam is able to take the shear force and able to withstand the bending moment or not. So, before going to shear force and bending moment diagram, let us first know what is shear force and what is bending moment. So before knowing what is shear force, let us first know what is force. Force means what? Force is an agent which can create or tends to create, destroy or tends to destroy motion in a body. That means whenever the force is applied on a body, it creates motion or destroys motion, or it have a tendency to create or destroy the motion in a body. But whenever the force is applied on the member, depending upon the direction of the force is categorized into two types. First one is normal force and second one is shear force. Suppose it is a member, here we will apply the force, then what will happen? The member will deform or it will break. But how we can apply the force? We can apply the force in this direction so that the member will be extended and it will break. Otherwise, we can apply the force in this direction so that the member will break from this portion. In both the cases, the member is breaking from this portion only. But the thing is that in which direction we are applying the force, that matters. So, whenever we are applying the force in this direction and the member breaks from here, if you will see, the force is perpendicular to the breaking area. See here, this is the breaking area and this is the force. The force is perpendicular to the breaking area. This type of force is called as normal force because normal means perpendicular. And in another case, whenever the force is applied in this direction and the member breaks from here, this is the breaking area. If you will observe here, the force and the breaking area both are parallel to each other. This type of force is called as shear force. Is it clear? So, force is categorized into two types. First one is normal force and second one is shear force. In case of normal force, the force is perpendicular to the breaking area, and in case of shear force, the force is parallel to the breaking area. Next, let us move to the moment. Moment means what? Every force is having a linear effect and it's having a rotational effect. Rotational effect means what? Suppose here is a member, I applied the force and the member moves in this direction. This is the linear effect. And here is a member and I am applying the force in this direction. Then this member is having a tendency to rotate in this direction. This type of effect is called as the rotational effect of a force. This rotational effect of a force is called as the moment. Again, moment is categorized into two types. First one is bending moment, second one is turning moment or twisting. Bending moment means what? If the rotational effect of the force causes the bend in the member or the bending in the member, that type of moment is called as bending moment. Here we can see, here is these two are the supports and this is the member, and here the force is applied. What will happen? Whenever this force will apply, the member is having a tendency to bend in this direction. So this type of moment is called as bending moment. And here you can see, here is the member and the force is applied in this direction and in this direction. So that means what? It creates or it is having a tendency to create the twist in the member. This type of moment is called as turning moment or twisting. So, as far as our shear force and bending moment diagram is concerned, we are more concerned about the shear force and bending moment. So, what we will study in this chapter? In this chapter, we will study that suppose a member is there or a beam is there, okay, and here the force is applied. This force, how much this force is able to create the shear force and how much this force is able to create the bending moment, that we are going to study here. So, before going to see about the shear force and bending moment diagram, as we are studying about the shear force and bending moment diagram of beams, so let us first know what is a beam. Beams are the horizontal members which support vertical load, that is tension, that may be tension, compression, or it is a moment or a bending load. Actually, the thing is that suppose the horizontal member, whatever you are getting in a structure, that is called as the beam. See, these are the vertical members, these are called as the columns, and the horizontal member is called as the beam. What type of load can come here? See here, suppose in a civil structure, above this roof is there, the total load of the roof will come here in this way. This structure is called as beam. So there are actually four types of beams are there. First one is cantilever beam, second one is simply supported beam, third one is overhanging beam, and fourth one is fixed beam. Cantilever beam means what? This type of beam is fixed in one side and overhanging in another side. You can see here, this beam is fixed here and it is overhanging in another side. This type of beam is called as cantilever beam. Simply supported beam means whenever the beam is simply supported from both the sides by two supports, this type of beam is called as simply supported beam. You can see here these are the two supports and it is the beam. Next one is overhanging beam. Overhanging beam is nothing but it's a mixture of cantilever beam and simply supported beam. You can see here overhanging beam. This is two types of there are two types of overhanging beams are there. One is single side overhanging and second one is both side overhanging. You can see here from here to here this is the simply supported beam and from here to here this is the cantilever beam. So it is a mixture of both simply supported beam and cantilever beam, and here this is the overhanging portion. As the overhanging is in one side, so this type of beam is called a single side overhanging beam. Here you can observe the overhanging is in both the sides, so this type of beam is called as both side overhanging beam. Next type of beam is called as fixed beam. Fixed beam means what? Here the beam is fixed from both the sides. Actually, the importance of types of beam is in such a way that according to the construction of the beam or according to the position of the supports, there will get the reactions that will read in the next time. Next, let us see types of support and their reactions. Basically, there are three types of support as per our subject point of view. First one is roller support, second one is hinge support, and third one is fixed support. Roller support means what? Here it is a beam, below that one roller or it may be a pin support will be there. Here you can observe, here we will get a point contact. So as we know, as many contact points are there, those many number of reactions will generate. So as here we are getting a point contact, so here we will get only one reaction is there. That is in the vertical direction. Second one is there hinge support. Hinge support means what? The beam is connected by means of a hinge. Here you will get two contacts, so you will get two reactions. One is along the horizontal direction and another one is along the vertical direction. So in case of roller support we are getting the one reaction, and in case of hinge support we are getting the two reactions. One is horizontal and another one is vertical. Third one is fixed support. Fixed support means what? As I had told you previously, these type of beams are fixed in both the ends or single end, whatever, but it is fixed. So in this case, you will get two reactions and another one is movement. One is in the along the vertical direction RV, along the horizontal direction RH, and another one movement. Maybe it is a clockwise movement, maybe it is a counterclockwise movement, depending upon the position of the beam or position of the support. So next we will see the types of load. Actually, as per our subject point of view, there are three types of loads are there. First one is point load or concentrated load. Second one is uniformly distributed load, which is also called as UDL in short form. Third one is uniformly varying load, which is also called as UVL. So first from the name itself we will see. First one is point load. Point load means what? The load is acting on a single point. If we will see here, if this is a member or this is the beam, W amount of load is acting on a single point. This type of load is called as point load or concentrated load. The calculation of this load is very simple. How much amount of load is acting, that much amount of load we will take into consideration. That means here W amount of load is acting in this point, so we will consider W amount of load at this point. Next one is uniformly distributed load. Uniformly distributed load means what? Suppose W amount of load is acting for an amount of length L. That means at each point W amount of load is acting. As the amount of load is same throughout the length, that is called as uniformly distributed. That means the load is distributed over the beam uniformly. So this type of load is called as uniformly distributed load. So how we calculate the load amount here? So here it's each single point W amount of load is acting, and it is acting for a length of L. So total amount of load at this point is W into L, or we can take that the area under this curve. Actually, how much the area the load is creating, the area of the load is also called as the total amount of load of this uniformly distributed load. If you will see here, W amount of load is acting and L is the length of the load. So the total load equal to W into L. By doing W into L, what we are doing? We are actually converting this uniformly distributed load into a point load. That means many number of loads were there. Now we are converting that one into a single load. So whenever we are converting that one into a single load, where the load will act? The load will act at the CG point of this beam. That means if the total length is L, the load will act at a distance of L by 2. And how much the load amount is? Load amount is W into L. This is the uniformly distributed load. Next we will see the uniformly varying load. In case of uniformly varying load, what is happening? The load varies from one end to another end, but in a uniform manner. That means at this point 10 Newton amount of load is acting, at the very next point 9 Newton amount of load is acting, at the very next point 8 Newton amount of load is acting. Like this, in a uniform manner the load is getting varied. So this type of load is called as uniformly varying load. But as we know, we can only solve the problems where the point load is applied. So that's why only here we have converted the uniformly distributed load into a point load. Similarly, here also we have to convert the uniformly varying load into a point load. For converting the uniformly varying load into a point load, if we will say, suppose here the maximum amount of load is acting W and the minimum amount of load is acting 0. So as it is varying uniformly, so you can get a triangle here. So how much amount of the load? The amount of load is nothing but the area under this triangle. So if the length of the beam is L, so the area under the triangle will be half into W into L. So this is the total amount of load acting at this point. So now by doing this is nothing but the load. By doing this, we have converted this uniformly distributed load into point load. As it is a point load, definitely it will act at some point. So in which point it will act? It will act at the geometrical center of this triangle. At the geometrical center of this triangle means, if you will see this triangle in this manner, this is the base and this is the height. Where the center will lie? The center will lie 1/3 x from this side or 2/3 x from this side. So if you will see from here, this is 1/3 L distance, the point load will act. Here the load will act, that will be half into W into L, and where it will act? It will act at a distance of 1/3 L from this end or 2/3 L from that end. We studied about what is shear force, what is bending moment, types of support, types of beam and types of load. So in the next video, we will see about what is shear force, what is bending moment, and what is shear force diagram and what is bending moment diagram and their sign convention, and for different various types of beams, how we will calculate the shear force and bending moment and how we will draw the shear force and bending moment diagram.